Alrighty, let's wrap up this chapter with 9.7, marginal analysis in business and economics. For our first problem, we have a polynomial, p of c, and we want to find p of 3. So all this means is that I want to plug in anywhere I see a c, the value 3. And I'm just going to plug it into our p function. So p of 3 equals 3. And so I have a c here, so 3, then I keep that squared, minus 14, I see another c, so I'm going to substitute in 3, and plus 9. And so you can use a calculator, or you can do this by hand if you feel confident in that. So you could also break it into smaller terms instead of having to do it all at once, however you want to do it, but you should get to -6. And then the same idea for p of 0, right? We're just considering when c is equal to 0. So again, I'm going to find p of 0 by plugging in 0 wherever I see a c. And since we're evaluating at 0, the first two terms actually go to 0, and so we're left with 9 as our p of 0. Okay. Same idea here, and now we want to know about p of 6. Now we have x's instead of c's, but we can still handle that just fine. Just plug in a 6 wherever you see an x this time. So again, you can do this by hand, break it into smaller terms, or use a calculator. All up to you. Oops. But you should get 46. All right, so now we're getting into the marginal analysis. So whenever we see marginal analysis or marginal cost, profit, revenue, that should trigger you to take the derivative. And it's kind of hinted here in the answer that we want to see prime of x. All right, so if we take the derivative of c of x, I have this 174. That's a constant, so its derivative is 0. Then I can move on to the next term. And the derivative of 0.9x, so x is linear here, so we just take the coefficient 0.9. And so our c prime of x is just 0.9. All right, let's do another one. So I have, again, a constant here, so that's going to go to 0. Then I have a linear term, so I'm just going to take the coefficient in front of it. And then my last term, we notice that it's an x squared, so I'm going to use the power rule. Let's keep that 0.04 on the outside, because that's a multiplicative constant. So that now we just have to worry about the derivative of x squared. So bring the power down, x, and then decrease the power by 1. So we can rewrite this a little cleaner and get this 3.2 minus 0.08x. All right, now we're looking at average cost function. So c bar or c average of x, we know that is going to be equal to our cost function divided by x, since we're taking the average of it. So my cost function given above is 131 plus 4.3x. And then to make it an average, I'm going to divide by x. And so we can simplify this. If you need to, you can break it up like this. Oops. X. All right, so these x's cancel, but nothing cancels here. So our average cost function is 131 over x plus 4.3. All right, so let's get some more practice. Here we want the marginal average cost function. So we should first find our average cost function that we just did previously. So c of x over x. It's going to be 130 plus 4.5x over x. So this is going to be 130 over x plus 4.5. Okay, but now we want marginal, and this tells me that I need to take the derivative. So I want C bar prime of X. And so that means I'm going to take the derivative of my average cost function that we just found above. Now I'm going to rewrite the average cost function just to make the derivative a little easier. So I'm going to rewrite this X in the denominator. And I'm going to make it go in the numerator, but when I do that, the power, which is 1 here, it needs to go negative. So all I did was just rewrite these two. They're equivalent. But in doing so, I can avoid having to do a quotient rule, which we'll learn about in the next chapter. But anyway, let's take the derivative of our average cost function. So I have that 130 just hanging out over here. Just rewrite it because it's being multiplied by this x to the negative 1. That's not a linear function. So let's use the power rule, right? It's got a power other than 1, I guess. So we bring the power down, write the x, and then decrease the power by 1. So just be careful because this has a negative power, that you're not getting your negative exponents mixed up, all right? And then the derivative of 4.5 is just 0. All right, so I'm going to move this negative 1, or you can multiply the 130 in. It's all the same. And I get x to the minus 2. And then you can also bring that x to the minus 2 back down to the denominator and make the power positive. These two are equivalent. All right, and so we just found our marginal average cost function, one of these two. Okay, let's do some application problems. All right, so in this problem, we are given the total cost of producing X food processors, this function here. And so we want to know what the exact cost of the 61st food processor is. Now, it's not as simple as just plugging in 61 into our cost function. Just because when we do this, we're finding the cost for 61 food processors, not the 61st one. So if we know the cost of 61, and let's say we can find the cost of 60 food processors, then maybe if I subtract the two, the difference, that would just be the cost of the 61st food processor. Does that make sense? So the difference between here, this is the first, second, third, all the way to the 60th food processor, and this set includes the first, second, third to the 61st processor. So by subtracting the two, I'm really just getting this cost. So that's what we're going to do. So to find the cost of the 61st processor, the 61 processors, we're going to plug in 61 into our cost function. So 2300 plus 40, plug in 61 for x, 0.161 squared. So you can do that in the calculator. Hope you won't do that by hand because that's a lot, but it's 4367.9. All right, so that's the cost of producing 61 food processors. Now let's find the cost of 60 food processors. So again, let's plug in 60 now, wherever I see an x. So if you were to plug this in the calculator, you should get 4340. And so my last step is doing the subtraction. So let me write this out. So we get 4367.9 minus 4340. And this gives me 27.90. So that's the cost for producing the 61st food processor, and only that food processor. For part B, we want to use marginal cost to approximate the cost of producing the 61st food processor. So in this chapter, we learned that C prime of x approximates Cx plus 1 minus Cx. So C prime, it approximates the next food processor minus the current food processor. And that's kind of what we found in this step. So by doing so, we can find the marginal cost to approximate what we just found here for part A. So let's go ahead and do that. All right, so first let's find C prime x. So looking back at our cost function, 2300 is a constant, so its derivative will be 0. That 40x, that's a linear term, so I'm just going to take that 40 along. And then the last term, minus 0.1 x squared, that I'm going to use my power rule, so bring that 2 down, x, and then subtract the power with 1. And so my marginal cost function is 40 minus 0.2x. So let's go back to what we wanted to find. We want to find this difference, right? The 61 minus C of 60, okay? We want to find this difference and approximate it using C of 61 or 60. So if we were comparing these two, we notice that the difference is when x is equal to 60. So that's why I want to find C prime of 60. And that's going to approximate the difference that we found in part A. So let's plug in 60 into our marginal cost function. And so this should give you $28. And notice how close they are, right? This is an approximation without having to do these two steps and subtract it. Instead, we can just take the derivative, or the marginal cost, and evaluate it at 60. All right? So hopefully that worked out for you. Let's see another application problem. So we have another cost function right here, and we want to find the average cost now if we have 100 frames produced. So let's first find the average cost function. Remember, that's just taking the cost function and dividing by x. So I have 30,000 plus 600 x over x, which gives me 30,000 over x plus 600. And so if we were to find the average cost of 100 frames, that's just plugging in 100 wherever I see an x in my average cost function. So that's 30,000 divided by 100 plus 600. And so this should give you 900. And that's our answer for A. Right, and B is asking the marginal average cost. So when I hear that word marginal, that means that I want to take the derivative of my average cost function. Right, this is the same as C prime, if you like that notation better. So let me quickly rewrite the average cost function like so. Remember that trick of bringing the x in the denominator up, but just changing the power to negative. Okay. So if we were to take the derivative of this average cost function, I'm going to keep that 30,000 out. It's a multiplicative constant. And now I'm just going to worry about that x and negative 1. Let's use the power rule, bring down the negative 1, x and then decrease the power by 1. Just be careful with those negative exponents. And then the derivative of 600 is just 0. So your marginal average cost should be 30,000, x to the minus 2. Or you could also rewrite it this way if you like a positive power better. All right, and let's answer the question. We want to know the marginal average cost at a production level of 100 units. So I want to take our average cost and the marginal, and we want to plug in 100, right? So let's just put that in wherever I see an x in my marginal average cost. And so if we do this division, it should be negative 3.00 per frame, right? Because it's dollars. All right, and that's how you answer this question. So let's go to the last part. All right, so I just included some information that we just found. The last part, we want to use these results from A and B and estimate the cost per frame if 100 frames were produced. So let's look here. So B, I'll write it this way. We found that the marginal cost at the production level of 100, that was negative 3.0. Okay, we can write it that way. So this means at the production level of 100 frames, our average cost is decreasing, because I have this negative, at a rate of $3 per frame. So for every additional frame after producing 100 frames, the cost will go down by $3. Right? So that tells us that our average cost of 101, this is the same as doing the average cost of 100 and adding on the marginal average cost that we found. So that's why it's kind of giving you a hint, use part A and B. So this average cost of 100, that's what we found in A. And then C bar prime, that's what we found in B, right? And then I have this negative 3. And so when you add the two, $897, right? And this kind of makes sense. Like I said, for the marginal average cost, for every frame over 100, the cost reduces by $3. So that's why, since we're only producing one more frame, 101, I'm going to subtract 3 from the cost of 100. Alright, so I hope you found this video to be helpful. Reach out if you have any questions, and good luck on your project and concept check. We'll see you for the next chapter.